Have you ever felt like your job as a data engineer is less about building cool new stuff and more about, well, just babysitting production? You're constantly reacting to outages, putting out fires, just trying to keep up with all the data, all the demands. It's tough. It feels like you're stuck in the cycle and it stops you from actually innovating.
Oh, absolutely. That's such a common story, isn't it? You push code, maybe without great local testing, maybe observability isn't quite there, and then bam, production failures. It creates this reactive loop. You're always playing catch up, never really getting ahead or paying down that tech debt.
Exactly. And that's really why we're doing this deep dive today into Dagster, because it's pitched as not just another orchestrator, but something built with a fundamentally different idea behind it. So our mission is to unpack Dagster's asset-first thing, look at its core ideas, and yeah, see how it stacks up against the big players like Airflow. Hopefully you'll get some new ways to think about managing data, maybe have a few aha moments along the way.
Right. So let's start with the basics. What is Dagster? At its core, okay, it's an open source data orchestrator, but the key difference, the thing that sets it apart, is that it's built specifically for developing and maintaining data assets.
Data assets.
Yeah.
So like tables,
Yeah.
models, reports.
Exactly. Think of them as the logical pieces of data your business actually cares about. It could be that critical table in your warehouse, a data set you've cleaned up for analysis, a machine learning model you've trained, or even that final business report, the tangible outputs.
Okay, so it's less about the how the individual tasks and more about the what the data products themselves. And this leads to that asset first philosophy you mentioned. That's the big paradigm shift, right?
That is absolutely the core idea, yeah. Instead of focusing on the sequence of operations, like task A, then task B,
Yeah.
Dagster puts those data assets right at the center. You essentially declare the Python functions you want to run and the specific data assets those functions produce or update.
You declare them.
Yeah, you say, this function makes this asset. And then Dagster handles the rest, figuring out dependencies, orchestrating the runs, making sure assets get updated when they should. It came out of Elemental, founded by Nick Schrock. You might know him as a co-creator of GraphQL. Dagster launched back in 2019. The whole point was really to bridge that gap between, messy pipeline development and the actual business processes that rely on the data.
Okay, connecting the tech to the business value. That makes sense. But why does this declarative asset first approach matter so much? What's the real win?
Well, think about modern web development. Maybe the shift from, say, older frameworks like Angular 1 to something like React. It's a move towards declarative UIs. Instead of telling the computer how to update the screen step by step, you just declare what the screen should look like based on the current state. Dagster does something similar for data.
Okay, like telling a chef make lasagna versus giving them every single instruction.
Exactly. You declare the desired end state, the asset you want, and Dagster figures out the best way to orchestrate getting there. The goal is to simplify these often incredibly complex data workflows. It boosts developer productivity, lets teams reason about their whole data platform more easily. And think about failures. If something breaks, instead of digging through logs trying to find which task failed.
Dagster points you to which asset is stale or broken.
Precisely. That's the aha moment. It shifts the focus from a process headache to a data-centric view. That means faster debugging, clearer understanding of the impact. It's a big deal for reliability.
Okay, that's a powerful shift conceptually. But, as engineers, we got to ask, how does this actually work when you're building stuff? Say I want that daily sales report asset. How do I define that in Dagster?
It's designed to feel very Pythonic, which is great for a lot of data teams. You write standard Python functions, but you add a decorator, like a dg.asset. That simple annotation tells Dagster, hey, this function produces a data asset. So your function that calculates daily sales or processes raw customer data just becomes a recognized asset. It feels a lot like writing regular software.
And I saw things like multi-asset and graph asset, so it handles different kinds of scenarios.
Yep, absolutely. If one function, maybe hitting an API, needs to update, say, 3 different tables,
You'd use at dg.multiasset.
you got it. One function, multiple distinct asset outputs from a single run. Then, if you have a more complex process, maybe several steps that all feed into creating one final logical asset, like a complex feature set for an ML model you can use at dg.graphasset. It lets you group those related steps together visually and logically. The docs have a good tutorial using DuckDB for ETL, building reports, running on schedules, or ad hoc. Shows this off nicely.
Okay, practical ways to structure things. But managing dependencies between all these assets, that's often where things get tangled in other tools, right? Keeping track of what needs to run before what.
This is a huge strength for Dagster, really. It automatically infers dependencies most of the time because you declare within an asset's function what other assets it depends on. Dagster just builds the graph for you. You're not manually drawing lines between tasks like in some older systems.
So the relationships are defined in the asset code itself.
Exactly. You just say, this asset depends on that other asset, maybe using function arguments. Dagster connects the dots. This scales really well. Whether you have 10 assets or hundreds, you can look at any asset and immediately understand its lineage, what produces it, what consumes it.
Okay, that sounds cleaner. Now, what about the actual data storage? Reading from databases, writing to lakes. Swapping those out can be a massive refactoring job.
Right, and that's where I/O managers come in. Honestly, I think this is one of Dagster's most brilliant ideas. They create a clean separation between your core logic, your data transformations, and how that data gets physically read and written.
Separation of concerns. Always good.
Totally. It means you can develop your transformations, maybe using local files or DuckDB, and then deploy to production using Snowflake or S3 just by changing the I/O manager configuration. You don't touch your core Python code that does the transformation. Dagster has built-in ones like DuckDB Pandas I/O Manager, Snowflake Pandas I/O Manager, handling the read-write details for you. Huge win for flexibility.
That is powerful. Okay, so building sounds good. Managing dependencies, handling I/O. What about automation and keeping the data quality high?
For automation, you've got schedules. Pretty straightforward run asset materializations, hourly, daily, custom cron, whatever you need. You can even set time zones for schedules, which is crucial for global operations. And then there are sensors. These let you trigger runs based on external events, like a new file lands in S3, or maybe an upstream system sends a notification.
Event-driven workflows? Nice.
Yeah.
And data quality, because bad data sinks everything.
Yeah, Dagster takes this seriously. It has built-in asset checks. You can define quality checks right alongside your asset definitions. Plus, the debugging is really good, detailed run logs, execution times, clear error messages tied back to the assets. And a key thing is the SLA-based alerting.
Tell me more about that. Alert fatigue is real.
Exactly. Instead of getting pinged for every little hiccup, you could set policies like, my daily sales asset should never be more than, say, 90 minutes stale. You only get alerted if that actual business-relevant SLA is breached. It cuts down the noise significantly.
Okay, yeah, that makes a lot of sense. So Dagster sounds like a really solid modern approach, but the elephant in the room, right? Airflow, it's everywhere, the established standard for many. How does Dagster really compare? What's the fundamental split?
It really comes back to that core philosophy we talked about. Airflow is fundamentally task-based. You build DAGs-directed acyclic graphs of tasks. Dagster is asset-based. Everything revolves around the data assets. So the mental model is different. Are you thinking about a sequence of steps or the data products you need to maintain?
And how does that difference feel for the engineer actually writing the code day to day?
Dagster often feels more like writing standard Python. You define assets with decorated functions. It encourages good software engineering practices. Airflow, while also Python, leans heavily on its operator ecosystem and Jinja templating for dynamic DAGs, which is powerful, but can sometimes feel a bit more specific to Airflow, maybe a steeper learning curve for the intricacies.
What about documentation?
Dagster uses Python doc strings directly. Your docs live right with your code, which is great for maintenance. And the UI renders Markdown in those doc strings, so you get rich documentation right there.
And local development. Setting up Airflow locally can sometimes be a bit involved.
Yeah, Dagster makes this super easy. You literally just type Dagster dev in your terminal. It spins up a lightweight local Dagster instance with the UI, scheduler, everything. No need to mess with local databases or web server config just to test your code. It's incredibly fast for iteration.
Okay, that's a definite plus. And deployment. I heard something about branch deployments.
Yes. This is a really cool innovation. Branch deployments basically give you an isolated, ephemeral, production-like environment for every single pull request. So before you merge, you can run your changes against real infrastructure or something very close to it without any risk to the actual production system. It massively boosts confidence and speeds up the whole deploy process.
Wow, okay. That sounds genuinely transformative for team workflows. What about the kinds of workflows each tool is best suited for?
Airflow is a fantastic general-purpose orchestrator. It excels at complex branching workflows, triggering tasks across many different kinds of systems. If you need broad task automation, it's incredibly mature. Dagster really shines, I think, in the core data engineering loop. Data ingestion, processing, transformation, machine learning, analytics. Its focus is tightly aligned with building and maintaining reliable data assets and the modern data stack.
And the communities. Airflow's been around longer, huge ecosystem.
Definitely. Airflow has a massive, mature community, tons of integrations, millions of downloads. It's undeniable. Dagster's newer, but its community is growing incredibly fast and is very active. There's strong built-in support for modern tools like dbt, Panda, Spark, DuckDB. Plus, they have Dagster pipes, which lets you orchestrate code written in other languages too, like R or Julia or whatever, which adds flexibility.
Right. So pulling this all together, we've looked at what Dagster is, how it works, compared it to Airflow. What are the bottom line benefits? What impact are companies actually seeing?
Well, first off, improve velocity. Teams consistently report faster development, testing, and deployment. That Dagster dev and branch deployment stuff really helps. Then there's hugely enhanced observability. The asset focus gives you clear lineage, detailed operational metrics, and much faster debugging when things go wrong.
Yeah.
You get better reliability. The design encourages testing, asset checks ensure quality, and the SLA alerting means you focus on real problems.
And it scales. From my laptop to a big production setup.
Absolutely. That's a key design goal. It offers great scalability, running fine locally, but also designed for large distributed clusters handling massive data volumes. And we touched on flexible integration. It plays well with the tools data teams are already using: dbt, Snowflake, Databricks, S3, Kafka, you name it. It fits into diverse environments.
Got any quick examples? Real companies using it?
Sure. Discord, for instance, uses Dagster to manage something like 2,000 dbt tables and over 12,000 dbt tests. It helps them manage that complexity and keep data fresh for their analytics. US Foods is another one. They talked about transforming their data infra from chaos to achieving like 99.9996% uptime using Dagster. These are serious results.
And for the really big players, there's Dagster Plus Play.
Correct. That's the commercial offering from Elemental. It builds on the open source core with features tailored for larger enterprises, advanced governance, security, user management, more sophisticated deployment options, that sort of thing.
Okay. So let's wrap this deep dive up. It feels like Dagster really represents a significant shift, moving data engineering away from just managing tasks towards managing actual data assets. It seems designed to bring much needed structure, observability, and just plain efficiency to building and running data platforms, making lives less about babysitting maybe.
Exactly. The core idea is empowering teams to treat their data outputs, tables, models, reports, as first-class products, with clear ownership, quality standards, lineage, reliability baked in.
Right. So as we finish up, here's a thought to take away with you. What would it actually mean in your organization to treat your data assets as true products? Imagine having that clear lineage for every key table or report, knowing its quality, letting stakeholders confidently self-serve because they trust the data. How could adopting that kind of asset-first mindset fundamentally change how you, your team, and your whole organization view and manage data?
It's definitely worth thinking about. We'd encourage you, if this sounds interesting, check out Dagster's open source docs, spin up a quick start project. It's real easy to get going locally. Or jump into their community Slack. See for yourself how this approach might help you build data platforms that are more sustainable, scalable, and importantly, observable.